afternoon. My talk is going to cover one of the ongoing projects we have on the development of a blockchain platform for supporting e-supply chain. It's one of the projects that we collaborate with industry organizations that specialize in the e-supply chain system. Before we get into doing the systems, we have a period of discussions. Why blockchain? At first, we don't want to do blockchain just because it's a hot topic and everyone wants to put the word blockchain in front of everything. So we did a lot of analysis and come to the point about what are the characteristics of a system that should take advantage from the features of blockchain, and whether the systems we're going to build will leverage on these features and maximize the benefit. So this is the background of our project. So in this work, we basically look at the blockchain as a distributed system infrastructure, looking at the system characteristics of the blockchain platform as a system service, and look at how to make use of this system service to support distributed applications and what type of applications we will take advantage of the service provided by the platform. And well, in this talk, I try to go through the analysis process and to come to the point about what are the key features that we identified from blockchain from the distributed systems angle. And from that features, we look at what are the things that we need from the distributed systems so that we can map the e-supply chain ecosystems into the system infrastructure provided or supported by blockchain. First is, as I mentioned, we try to go through the thinking process from the time that we decide whether we debate whether we should use blockchain. So first is why blockchain. I mean, if we look at the history, the initial idea is because conducting transactions through a trust provider is expensive. Basically, if you look at, I will have a slide later on to look at in the e-supply chain ecosystems, there are various stakeholders, there's various parties that need to perform transactions. Now, in the traditional world, a lot of those transactions is being conducted through a trust provider. The trust provider can be a financial institution, if you talk about trade finance, or could be a trade platform provider. So, but after all, the belief is, or at least the perception is that conducting transactions through a trust provider is costly. Now, as a result, people start to think about whether we can have a vehicle or some instrument that allow transactions to be conducted without a trust provider. So that means we try to make things open to everyone. So there's no one who can deny the commitment of certain transactions once it's committed. Now, that's the background of having cryptocurrency at the first place. And in order to support cryptocurrency, there's concerns about possibility of double spending. So there's a need to track or trace the movement of the digital currency or the changing hands of the cryptocurrency. That's why it gets to the point of having the blockchain, which is basically a way to track and trace the digital currency. And after a while, it's also what we mean by this distributed ledgers. Now, but as things evolve, now we get to the situations that we have already observed this in quite a number of countries. Regulators are not especially pleased with cryptocurrency. I think it's because of the way that the regulation is difficult to enforce or apply. But at the same time, there are lots of people still talk about blockchain. It seems that there is a trend of segregating cryptocurrency from blockchain. So we look at this situation. Then, of course, on one hand, we also ask ourselves, do we really believe in the future of cryptocurrency? I won't tell you what our conclusion is, but obviously by the fact that we're working on this project is at least we look at the characteristics of the blockchain. We believe there's certain system functions or features that we can take advantage of. And that's why we start to look at, so what are the type of blockchain applications that will make sense? Or in other words, what applications are blockchains suitable for? So this is the background of this project. And after all, we come to the point that we make use of the blockchain to perform track and trace of digitized asset, not just about cryptocurrency, but any form of assets as long as it can be digitized, so that we can record the state information of the digitized asset in the blockchain so that we can track and trace the movement. So then now we get to the point that we thought, and we still think so, that the blockchain can make sense depending on what we want to do with it. But certainly, as I keep telling people, today's blockchain is like cloud computing about 18 years ago. Everyone's talking about it, but not many people can tell you what does it mean. And everyone says it. If there's any problem you cannot solve, put it in the cloud. But what is in the cloud? What is the cloud? Now we're getting the same situation that it seems the blockchain is a solution to or answer to everything, but it's still waiting for a definition that can fit the role of being a answer to everything. So now we get to the point that we know why we want the blockchain based on the common understanding of the features of the blockchain. But what is a blockchain? Again, depending on who you speak to, depending on who sell you the idea of the blockchain, they could mean different things. Again, it's like when we look at the cloud 18 years ago. Different people have different understanding, different definitions, or different specification of the cloud. It's just an acronym of being good, being useful. So for the blockchain, we also need to look at, so what is it really up there that we think it can solve our problem? In this case, it's the e-supply chain. And of course, we start with the idea, as I mentioned, starting from the common understanding of the functionality of the blockchain is the distributed ledger. And of course, people talk about this as being immutable, being accessible. It's all because it's fully replicated, and because it's fully replicated, and it's because of the way that the data is chained together with historical data. It's like in crypto terms, it's like those cyber block chaining. You cannot resequence them. You cannot modify any of the bit unless you modify everything from the beginning. So that is through the structures and the replication of the data to make it to meet the sense of being immutable. So it is from the concept of the distributed ledger, we get to the point of this abstraction of a fully replicated distributed database. And because of that, because it's fully replicated and depends on where we replicate the data to, it's effectively a kind of global data with update history. So at first, it could be the global data with the update history of the cryptocurrency, so that people can track the changing hand of a cryptocurrency or a unit of cryptocurrency. And that's why we look at, if we look at digitizing assets. So in the case of the supply chain, it could be goods that is being traded. And so for the goods which is starting from as an output of the manufacturers, or to an item in the warehouse, or to a container in the shipment, and then get into some smaller units in the retail shops. So all this could be digitized assets. So in this case, it's the goods that's being traded. So with these characteristics, we start to look at whether we can look at the digitization of the merchandise or the goods, starting from the point that they start to be traded between the buyer and seller. And so that if we talk about in the trade ecosystems, we have the financial institutions that provide the trade finance. They can also keep track of the movement or the shipment of the goods so that they can disburse funds without worrying about fake invoice. So especially when we talk to people from the financial industries in the area of trade finance, they worry about fake invoice or the same invoice being sorted or being remitted multiple times. So these are some of the reasons that we think if we make use of the blockchain as being a global shared data with update history, we can use it to implement the track and trace concept of the goods which is being traded. Now, with this, as I mentioned, with this global data, we can basically put anything into the data, which in the case of cryptocurrency is whose wallet is this Bitcoin is being in. Or in our case, we could be talking about at what status of the transaction is the goods being in, which could start from the point of a purchase order being committed, or a warehouse receipt being issued, or bill of lading is being issued, a trade finance document or letter of credit is being issued. So these are the various state of a transactions in the e-supply chain ecosystems. So we look at digitizing the various documentation in the e-supply chain cycles, and we put the state information of all these trade documents as part of the records in the blockchain. So that's how we get to the point that from this global data with update history, we get to the point of using it to store shared state information about a transactions. Then, in fact, it can be any information. In our case of trade finance, or in the case of e-supply chain, it could be the state information for the transactions. In the case of cryptocurrency, it could be the state information of the cryptocurrency. So it could be any digitized asset. So if you can generalize it to any digital informations, so we can basically treat this as a distributed system service for for global sharing of information. So what is it? Why is it so important to have this globally shared data? I think the key point is, as people tend to talk about nowadays, is with this global view of the state information, then we can perform smart contract executions. But why smart contract? Basically, again, we look at it from the distributed systems model. Lots of traditional distributed system design involve modules or distributed modules running in different nodes, but still managed by the same organization or under the administration of the same organization, or at least within a kind of consortium. So for example, we have a distributed systems within a multinational corporations, or we have multiple process distributed nodes connected by some international service provider. So after all, they are still pretty homogeneous within the same kind of platform or framework. Whereas in the case of e-supply chain, we're talking about manufacturers, we're talking about distributors, retailers, logistics company, financial institutions. They come from different domains. They've come from different industries. So historically, there's hardly any shared infrastructures for this type of organizations to have a common view about a transactions. So because of that, we did our analysis. Historically, even within the financial industry, in the trade finance payment, you can have the traditional financial network. Or within the trade domain, the buyer and seller, they have these trade portals to support the transactions. Whereas when it comes to cross-domain transactions, a lot of time they have to manually print the document, sign it, stamp it, and then courier. So the other side may need to do the manual data entry, scan the paperwork back into the systems. So that means once it's cross-domain, there are lots of manual paperwork involved because of the lack of a common infrastructure that allow all these distributed components to communicate online. So that's why we look at the blockchain as a distributed system infrastructure that support cross-domain, cross-industry components to interact, so that we can use it to support execution of the smart contracts, which to us is a kind of distributed application programs. Now, this is a very oversimplified diagrams about the supply chain ecosystems, which involve building blocks like the manufacturer, the distributor, and the retailer. It moves down the supply chain from the manufacturing to the distribution and to the retailer. And at different part of the ecosystems, the form of payments is so different. So when you talk about buying and selling between the distributor and the manufacturers, they most likely talk about trade finance because they're talking about containers of goods. But when it comes to the interactions of the payment between the distributor and the retailer, we could be talking about cartons of goods. So you get to the concept of e-check as a payment instrument. But then when it gets to the retailer and the consumer, then we could be talking about mobile payment or e-payment. And also when it comes to logistics, we also talk about the warehouse, the shipment, and the delivery. So it's a very heterogeneous kind of ecosystems involving stakeholders and parties. They come from different industry domains. So as I mentioned, historically, we don't see a lot of common infrastructures that help interconnect all these people or all these parties together. Now, not to say that they can't do it. I think people have this tendency that they don't like to shake the boat, rock the boat and shake up the systems unless everyone believes the same thing and everyone commit and jump together. So in this case, I think the strange part about blockchain nowadays is not that we cannot find a different way to solve the same problem, but it's just in this few years, it's like cloud many years ago. It's just at this point, if you say you use blockchain, everyone say, okay, we should do it. We cannot ignore it. So it becomes a good reason, good excuse to build a new system infrastructure with these characteristics to support these cross-domain, cross-industry infrastructure services. And of course, as mentioned, there are also other stakeholders or participants in the ecosystems, including the legal paperwork and some regulatory or government authorities as well. So we look at the blockchain from different perspectives. First is the trust model. As I mentioned, the traditional model is we do transactions through a trust provider. So a buyer and the seller, they never met before. They buy and sell things through the bank, like through some financial instrument, so that I don't ship you the goods, and even though you don't pay me, and then I don't pay you even though I have not received the goods. So in this case, no one wants to move first. So then we both together pay some service fee to the bank. The bank is the trust provider, and then I know if I ship out the goods, once the good call on the port, I will receive the money, and likewise to the buyer, I know where as long as once the goods is called on the port, I can then pay. So I don't need to pay first before I see the goods. So this is the trust model. Now with this, we look at how to do transactions without a trust provider. So basically everyone plays a part to be a trust provider. And this kind of trust model, we start to see some countries, they start to build, for example, public key infrastructures. Now in the old model of public key infrastructure, we have a trusted third party the authority that everyone trusts, and then they issue public keys, certificates. And now we start to see countries, they start to get rid of the public key infrastructures or the certification authority and use the blockchain platform to say that this public key is owned by this entity, this public key is owned by this identity, so that we get rid of the trusted third party. So this is one fundamental change in the area of trust model. Now, this is especially useful if we talk about cross-country transactions, because if we conduct transactions within the same countries, it's quite unlikely that you cannot find a trusted party, because basically, historically, we've been trusting the same parties, whether it's the bank that everyone knows is in these countries or some government operations or government service that everyone trusts. So historically, this is not an issue. So that's why if we confine ourselves to a domestic scenario that everyone or all the transaction stakeholders are within the same countries, it's quite unlikely that we cannot find a trusted third party. But if we talk about a typical supply chain, the manufacturers and the buyer, they are likely to be from different countries. So in this case, it's more difficult to find a trusted third party because it's cross-industry. And this is especially so when we talk about not only it's cross-country, but it's also cross-industry domains. As I mentioned earlier, traditionally, if the industry sector is big enough, organizations within the same industry sector may have some international organizations to come up with the infrastructures to enable these transborder transactions. But if we talk about this type of cross-domain transactions, we are less likely to be able to find this type of trust providers. So we are under this scenario, this model, that we think we need a different way of providing or implementing the trust model in order to fulfill the requirement of the supply chain ecosystems. So basically, we look at it as a security infrastructure. I mean, the blockchain as a security infrastructure to support transactions, so that it becomes part of the cyber system platform, that different organizations can conduct transactions in the cyberspace through this type of trust platforms without a centralized trust or trusted third party. Now, this is some of the supply chain requirements that we gathered from our industry collaborators. Our industry collaborators has come from different countries. So this is some of the requirement. Of course, ultimately, what we want to do as a functional requirement is the track and trace. And because of the track and trace, if we talk about the supply chain, because of the trading, the payment, the logistics, there are lots of documentation requirements. So we also, by working with the industry collaborators, we identify all these documentation requirements. And at what stage of the transaction we need to verify what types of documents that is needed to support the completion of the transactions. But one key thing we are asked to look into is the privacy or the confidentiality of the transactions. Now, this is the conflicting part of using the blockchain as a platform for supporting cross-transborder transactions. On one hand, if you look at the historical or the original model of the blockchain, everything is open. Everyone can see all the update records of the cryptocurrency. Now, for cryptocurrency, this may be okay. But if we do it for supply chain, now people start to ask these questions. If I am a distributor, a competitor will be able to mine through the blockchains to calculate my inventory. And my inventory level will directly affect my pricing strategy. And I would not want to jeopardize my pricing strategy because people are able to find out my inventory. So because of that, we start to look at, what are the protection requirements for the blockchain, which should not be the same as the original concept of the blockchain for supporting cryptocurrency. So we start to look at what type of blockchain we want to have in order to support this type of requirements. So then we start to look at different types of models for access control, controlling access to the trade documents, controlling access to the transaction records, and also controlling access to the particular transaction records. And also we look at in the long run, we also want to look at the scalability of the blockchain. We don't want to get to the same situations that the blockchain record, once it's in the systems, it will be there forever. So the blockchain will only grow bigger and bigger. So after a while, I mean, if this thing doesn't really work in the long run, it's not an issue. The problem if it's really useful, it will get to the point that it flood everyone's storage. So then what should we do? So we also look at some protection and group administration mechanisms to look at how to control access to a transaction record or to a collection of transaction records, and also how to allow us to purge the records related to a transaction if the transaction has been there for too long. You know the transaction has been closed. You know even the goods is being consumed by all the consumer. You know after it's consumed, no one complains. So you may want to remove it from the blockchain so that at least we know the blockchain will not just grow forever. So I guess this type of mechanism is more suitable for, let's say, track and trace of food items, for food safety, for example. The good things about food is you have an expiry date. After certain months, from the expiry date, I think we can safely remove it from the blockchain because you don't need to worry about people complaining about eating the food and got into stomach problem, because after a few months, and you shouldn't be eating it anyway. So if you eat it, no one is going to investigate. So this is some of the issues. But after all, what we want to look at is as long as the transaction is still alive and still active, we would like to protect the confidentiality or the sensitivity of the data because it directly affects the business of the stakeholders. So that is one of the privacy concerns if we use a blockchain for supporting B2B transactions. And so this is some of the documentation requirements related to the supply chain ecosystems, like document processing and approval. Currently in the supply chain management, you have a lot of paperwork. And with the paperwork, it's easy to subject to tampering, fraud, counterfeit, and things like that. So that's why we look at how this type of global shared information about the state of a transactions can help address all these issues, which the traditional approach may not be able to address. So this is our model of the blockchain as a distributed systems. So basically, we have this abstraction of the blockchain as a distributed system service. You can also treat it like a cloud if you want. So it basically, to me, I don't care how it's being implemented, as long as I can access it through an API, and this API allows me to inject a record, create a record, update a record, verify a record, or read a record, then I'm okay. So basically, if you look at this diagram, we are basically treating the blockchain with the abstraction that it's a globally accessible distributed system service to allow sharing of state information. Now, if you do distributed systems architecture, you will know that almost all the distributed systems can be modeled through shared memory. So what we want to do is to treat the blockchain as a shared memory. In this case, of course, the scale is different. The latency or the delay could be different. But at least in terms of organizing a distributed system architectures, we can model it this way. So with this, we can use this shared memory to detect invalid transactions, to detect double spending, or to do track and trace of movement of assets. So with this, why we call this smart contracts? After all, if we talk about distributed systems, we have process A, process B, process C. They are running different nodes over the wide area network. They need to synchronize. How to synchronize? Again, it's either through message passing or through shared memory. So the traditional way is, of course, through message passing. But when we talk about so many parties being involved, if we do a message passing, even though we do a multicast, it's going to be quite messy. The best is whatever I want to do with the transaction, I create a record with the state information of the transactions in this global shared memory. So all the processors can look at the state information of the shared memory to decide what it does next. So it's a kind of synchronizing the distributed components in a wide area distributed systems. So this is how we model the blockchain as a distributed systems. So that's why when we look at smart contract, it's basically a distributed processing components running on a node, connected through the wide area network to access the shared memory in order to synchronize its actions with another node. So that if, let's say, we talk about trading, if when the goods left the warehouse, so there is a warehouse receipt being written to the blockchain. Then next is, then the logistics company can look at the blockchain to see that we need to prepare for the container. So then once it go to the shipment, then there will be a bill of lading into the node. Then the bank that provided trade finance will be able to trigger the payment automatically. So all this can be automated. Unlike in the traditional world, as we mentioned, there are lots of paperwork involved. Even though within the same domain, within the same industry, they can do a lot of automations, automatic processing. But once it's cross-organization or cross-domain, we still rely on a lot of paperwork. So in this case, we can get rid of a lot of paperwork if we synchronize the various organizations or the various distributed components in this through the shared memory. So this is the essence of the way we model the blockchain as a distributed system service, so that we think we can make a lot of sense out of the blockchain platform, not just about cryptocurrency or ICO. Now with this, as I mentioned, we can, once we have the platform, then we can start to provide the API to access the blockchain platform as a distributed share data. And then we can start to build distributed components, which we call this smart contracts, so that they can work together. So this is, with this platform, then we can perform executions of transactions at various nodes. And the executions are synchronized through the blockchain platform. So, as I mentioned, it's through all this analysis, how we look at the blockchain as, or how we model the characteristics or the abstraction of the blockchain, and then we try to identify what could be the most sensible things to do if we have such a distributed system service. And that's why we get to the point that the e-supply chain ecosystem could be a good applications that can make a lot of sense out of it. So to summarize, we basically look at if we have application systems that is cross-country, cross-industry, and cross-organization that need to share data. In this case, it's the transaction state informations. So these state informations of the goods or products throughout the life cycle, which involves parties like the manufacturers, the warehouse, the shipment, distributor, and retailers. And in our case, we even include the consumer as well, so that the consumer can visit the blockchain platform to see the history of the goods that they bought from the retail store. But as I mentioned, because of the privacy issue involved, so we also look at the access control requirements. Of course, the most fundamental is like who can create or to update or to read the records. So we need to implement certain type of access control mechanisms to make this possible. So for this, this project is only halfway through. So we already come up with the idea, the concept. Implementation is still halfway. So usually my style is before it's fully implemented, I tend to be more low profile because don't know how good it's going to be. And then the second thing is who can read the records. As mentioned, accessing the record could be sensitive depending on what type of information we put into it. So we would like to enforce certain type of access control policy so that depending on the nature of the state information or depending on the nature of the transactions, we know what to do to protect the information. And also we want to look at the granularity of the records. If you look at the blockchain, the original proposal is one block, many records. And if we talk about transactions, the trading transactions, one record could be one container. Once you open the container, there could be hundreds of cartons. Once you open the cartons, it could be hundreds of bottles or dozens of bottles of certain things. So in our systems, we talk about dangerous items like pesticide. So starting from the dangerous hazardous chemicals to the manufacturing process, then come up with containers of pesticides. So from the container, you have cartons. From the cartons, you have bottles. So then the granularity of the record is another issue we have to look into. So as I mentioned, we most likely would want the consumer to make use of blockchain platform to do a track and trace of where this thing come from. But from the manufacturer or from the distributor's point of view, we may not someone to have the capability to access the blockchain to mine the inventories or the throughput or the turnover of the organizations. So these are some of the things that we need to enforce as part of the access control mechanisms. And the other thing is no trusted third party is available. As I mentioned, if we talk about one single country, it's quite unlikely that we cannot find a trusted third party. If we talk about one industry domain, it's also quite unlikely that we cannot find a trusted third party. So that's why we look at the supply chain ecosystems where we have cross-country transactions with players from different industry domains. So historically, they don't have a common infrastructures. And that's why we take this opportunity to build this cyber system platform as the common infrastructure for supporting these supply chain ecosystems. So that's why we end up modeling the blockchain as a system service, probably with some privileged access to create and write records or to create and write operations. And probably we can have open access to the read operations, depending on the nature of the record. So we also start to define different types of records. Certain things can be accessed with open access. Certain thing is not allowed. We are still halfway through looking at the granularity of the access control. So this is one of the implementations that we have done. Actually, right now we are running 3 nodes in the NCL here. I'm not going to get into detail, but what I illustrate in this diagram is that in the blockchain record, it records details of the transactions, and the transaction records details of the transaction documentations. But we don't store the document into the records, but we store the hash value of the document, and then some other delivery details. So in terms of security access requirements or access control requirements, we look at different levels. First is to access to the nodes, and then it's to access to the records, and eventually it's to the access to the document contents. So we use different mechanisms to address the control at different layers. So for the blockchain nodes, this is a tough call. We still have not come to a consensus. What is the best way to enforce access control to the blockchain nodes? But to the records, we more or less have the idea that we are implementing it. But for the document contents, basically the control is through cryptographic means. That means we encrypt the document before we put into the open data storage. So that even though you have access to the document, but it's encrypted, unless you have the cryptographic means to open it. So as I mentioned, with these 3 tiers of control, the document layer we already implement. The record layers we are implementing. The node layer we are still working on it. So this is the system architectures that we implement. As I mentioned, we replicated 3 nodes in the NCL and 1 node in China. So altogether, I think 5 nodes, 1 node in Singapore in the company and 1 node in China, the Chinese office of the company, and 3 nodes in NCL. So altogether, we run 5 nodes with the transporter deployment. So with this, we already have these things that at least minimally can operate, can perform transactions. So we currently working with a few organizations in these regions. So to do a testbed, so that we can use this platform as a testbed for transporter transactions. So we have organization or collaborating organizations from Hong Kong, Taiwan, Malaysia, and Thailand to do these transporter transactions. Why we talk to this organization in these different countries? Because you look at these different countries, they are traditionally strong in certain things. One is to export raw materials. One is to do manufacturing. One is to do financial services. Or one is a logistics hub. So we work with organizations. They have a traditional role in different parts of this trade finance, this supply chain ecosystems, so that we work together to form this testbed, so that we can build blockchain applications to test the idea of applications that fulfill what I mentioned earlier, that is transporter cross-industry. And we want to automate the transaction processing through this cyber platform. So this is the idea of the transporter testbed that we already created with the various organizations in the region. So I'm not going to the details of this. Is basically some of the explanations about how we use this platform to do transporter activities, because some of our collaborating organizations, they already built a blockchain platform to do trade finance. One of the partners, they already built the platform to do credit services. One of the partnering organizations, they already have a platform to do supply chain. So basically, we work with a number of organizations, the regions, to form this transporter testbed to test this type of ideas. So with this, I finish my 45 minutes. Thank you.
Are there any questions for Prof. Lam?
Hi, Professor Lam. There is a project named Hyperledger Fabric, and they claim they also care about privacy. They also can trace. They also they also have access control. So what's the difference between your design and Hyperledger Fabric? Thanks.
Okay, first answer. I don't know this platform that you talk about. Okay. And nowadays, there's so many people who make so many claims. I won't have the time to read everyone and make a comparison. So what we are doing is we look at an R&D as a system infrastructure or system research R&D to identify system services that we think needs to be implemented. Then we do the system architecture design to build it. But I have not done any analysis with every other platform. Of course, for those more important one, we did the comparisons, but not so many different types of things that every day people make announcements. We don't have the time to do the comparison. Thank you.
Okay, thanks.
Other question?
Thank you for sharing the excellent application. So we're very curious about in the application studies with your rich experience. What are the key limitations you have identified for the blockchain as a system service with respect to the fundamental things about blockchain itself? Is it scalability or some other issues like we discussed in the seminars today? Thank you.
Certainly, scalability is one. We start to worry about this. Of course, as I mentioned, if we assume that this thing will die a few years later, then we don't need to worry. But we of course, when we do something, we hope or we expect it lasts longer. So if all the transaction records is going to last, with all the update histories are going to be there forever, no matter what you say, I don't think it's going to be a scalable infrastructure, or it's not going to be scalable. So we need to have way that we organize the data structures, to we organize the transaction history in such a way that if we think it's possible to purge old stuff, we can do it. Or at least if we want to archive it, we can conveniently, efficiently take the thing out of the online platform. So that's the scalability part. The other part is the privacy protection. As I mentioned, I kept emphasizing this point, is the original idea of the blockchain is because it's to track cryptocurrency. So $1 is $1, $2 is $2, nothing much to protect about. But if we look at it the other way, it's not about who is owning this money, but it's about what I own at this point. Then I start to worry about people can access my capability, my inventories, my assets. So this become a more sensitive issues. So that's why we start to worry about this, or what we call commercial secrecy, as an issue. But I will call this commercial secrecy, but a lot of people like to call this privacy. Since we also have a privacy research center, so I just take that terminology. So these are the two major issues. Then of course, if you look at consensus, so far a lot of people talk about consensus. I start to implement consensus protocol 30 years ago, starting from my PhD time. And it's very difficult. As I discussed with my own colleagues not the current colleague now, but my colleagues many years ago, I also feel that if you look at all the theoretical paper, the replication consensus of n parties, the n can be any number, but we will tend to have the conclusion that if n is bigger than 3, things become haywire. So we're still looking at what would make more sense if we want to do a large-scale replication. And the other thing is, even if we can do the replications with consensus, I think depending on how we put enough assumption in all the scientific or all the theoretical algorithm, nothing is unsolvable as long as you put the assumption there. So if we put sufficient assumptions to make it workable and yet realistic, the issue is, are we really going to replicate every record in every node? This is especially an issue when we talk about transporter transactions, because there's certain transactions, whether it's due to regulatory issues or company policy, certain transaction details, they may not be allowed to record outside of the domestic market where they have their license in. So if we take the real generic blockchain approach, every piece of data is fully replicated. That may hit into regulatory issues. So this is another thing that we're looking at, how to selectively, or at least how to allow these replications to be configurable, whether a piece of data can be replicated everywhere, or only at the transaction creation time we can configure where is it allowed to replicate to. Okay, so these are some of the issues. Yeah.
Hi. Hi, Prof. Actually, thanks for your session. It was very informative. I have one question. Like these things we are listening from like past 1-2 years, the ideas. But what is your view onto how many years it is going to be implemented live, and people, especially considering the problems in the ground level, like you talked about paper stuffs doing. So people are quite comfortable when the transaction is happening, they have to sign and that's it. But when you are bringing the coding and the technology into that part, so this is a quite challenging thing. So I mean, where are we and how many number of years it is going to take to imply this?
Well, I don't have the crystal ball, even though I read this is co-organized by Crystal Lab. But, okay, I think if you look back, I'm old enough to see lots of gimmicks for the past 35 years. Big ideas came and left and bust. But those that survive usually are people who really find a compelling reason to use it. Not just because it's a hype or everyone just, no matter what, just use it. You use it for the sake of using it. Now, I've seen this for PKI, for example, 20 years ago. Everyone thought about PKI because that's how e-commerce became a buzzword. And then people ask, then e-commerce needs security. Then people will say, immediate answer is PKI. You build a PKI, you have security. With security, you can do secure e-commerce. That's the logic 20 years ago. So the lots of PKI suddenly appeared and disappeared because the people didn't look at the nature of the transactions that really deserve the use of a PKI. Don't forget that was 20 years ago. To do a 1000 bit RSA requires about 1 second on a PC. Unlike today, you do a 2000 bit RSA on a handphone, it could be a fraction of a second. So in those days, a PKI was costly. So at that time, I was in NUS at that time. So we've been trying to tell the industry, this is not the way to use PKI. So in fact, at that time, we designed something else. And we could be in the best positions to benefit from this hype. But we decided not to because we thought it doesn't fit for the purpose. For example, you don't use PKI to protect a consumer transactions because consumer transactions is very, very low value. And for low value transactions, you use lightweight security. So in those days, we saw systems use a heavyweight PKI to protect a few dollars. So which doesn't make sense. So coming back to your questions, that's why we spend so much time looking at why we want to do blockchains. Even though lots of people came to our lab and asked us to do collaborations, asked us to work on the blockchain, so we've been trying to be very selective. We try to look at why we want to do it or why the industry collaborators want to do it. So we have to convince ourselves that blockchain is really have a role to play in the applications, not just for the sake of using it. So whether it's PKI, of course, 20 years ago, we saw a lot of PKI came and left, appeared, disappeared. But today, PKI is everywhere. So and eventually you need to apply the technologies or the algorithms into the right place to solve the right problem so that people will agree that this overhead is justifiable. So the same to the blockchain, if you ask me, it's costly. Even if you don't talk about the computing node or the storage, hiring people who can do blockchain programming is already costly, especially in the last 2 years. So in order to justify this, we need a compelling reason to look at applications that really can benefit from blockchain. So if we are in the right directions to come up with the infrastructures, we can do it in 1-2 years. And we can at the same time start to build applications. So I would say, realistically, maybe 2 years, 1 to 2 years time, we can start to see a generation of blockchain applications that is sound and justifiable for the kind of overhead and investment people put into to come up with the systems. I hope I answer your questions.
Thank you very much.
If I can add, in a recent
Yeah.
blockchain summit, there was some slides with this Gardner curve, and the study says 6 years. 2024 will be the adoption. It's not by me, but I can give the link to some of those presentations from the blockchain summit in Suntech a month ago, I think. So this is from the, I think, KMPG or some study like this. Of course, no one knows really.
Okay, if there's no more questions, is it tea break now?
Yes, it's time for the tea break. Yeah, thank you
Okay.
so much for everybody's participation, and thank you, Prof. Lam. Yeah.